A spacecraft the size of a small car, built with technology that is older than the internet, older than the personal computer, older than the mobile phone, is right now flying through a region of space that no human instrument has ever explored before. And it just picked up something that scientists are calling one of the most unexpected and important discoveries in the history of space exploration. This is not a theory. This is not a simulation. This is real data coming back to Earth right now from the most distant human-made object that has ever existed. And what that data is showing us is forcing scientists to completely rethink what they thought they knew about the space between the stars. Let us start by making sure you understand exactly what kind of machine we are talking about. Because the first time most people learn the full truth about Voyager 1, they cannot quite believe it. The spacecraft was launched on September 5th, 1977. That is not a typo. 48 years ago, it was built with 1970s technology. Its computer has less processing power than the cheapest calculator you could buy today. Its memory can store roughly 69 kilobytes of data. For comparison, a single modern photograph on your phone is probably 3 or 4 megabytes, which is more than 40 times the total memory of Voyager 1. The spacecraft runs on 3 nuclear batteries, powered by the natural radioactive decay of plutonium. Those batteries lose roughly 4 watts of power every single year. And yet, despite all of this, Voyager 1 is still alive. It is still functioning. It is still transmitting data back to Earth. And it is doing so from a distance that is almost impossible to put into human terms. As of mid-2025, Voyager 1 was located approximately 167 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, roughly 93 million miles. So 167 astronomical units is about 15.5 billion miles, 15.5 billion miles from Earth. When Voyager 1 sends a signal home, traveling at the speed of light, the fastest thing that exists in the universe, that signal takes more than 23 hours to reach us. Nearly a full day, just for the signal to travel one way. And then another 23 hours for our response to reach the spacecraft. By November 2026, Voyager 1 will be the first human-made object in history to reach a distance of 1 full light day from Earth, which is approximately 16 billion miles. That milestone has never been crossed by anything we have ever built. It will be crossed for the very first time by a 49-year-old spacecraft, running on power equivalent to a dim nightlight. In 2012, Voyager 1 crossed the Heliopause. That is the name scientists give to the boundary where the influence of the Sun finally gives out. Inside the Heliopause is the Heliosphere, the enormous magnetic bubble that surrounds our entire solar system and everything in it. The Sun generates a constant stream of charged particles called the solar wind, and that solar wind pushes outward in all directions, creating this protective bubble. Outside, the bubble is something completely different. Outside, the bubble is interstellar space, the space between the stars, a realm that no human probe had ever entered before Voyager 1 crossed that line on August 25, 2012. When Voyager 1 entered interstellar space, scientists had certain expectations about what it would find. They knew interstellar space would be cold. They knew it would be sparse, almost nothing in terms of density. The interstellar medium, as it is called, the stuff that fills the space between the stars, is incredibly thin. We are talking about an average of less than 1 atom per cubic centimeter. For comparison, the air around you right now contains roughly 26 billion molecules per cubic centimeter. Interstellar space is essentially as close to nothing as nature can get. And yet, even in that near nothingness, Voyager 1 has been finding things that scientists did not expect. Things that are changing our understanding of what lies between the stars. The first major discovery came in 2021, and it was described by one of the scientists who found it as detecting the faint, persistent hum of interstellar gas. Here's what happened. Voyager 1 has an instrument on board called the Plasma Wave System. This instrument detects vibrations and charged particles, essentially listening to the electrical activity of the space around it. In the early years of Voyager 1's interstellar mission, this instrument was mostly hearing isolated bursts and whistles, spikes of activity caused by shock waves from the Sun smashing against the boundary of the heliosphere and reverberating out into interstellar space. Scientists compared these bursts to lightning in a thunderstorm. Dramatic, detectable, but sporadic. Between those bursts, scientists thought interstellar space was essentially quiet. A team of researchers led by astronomer Stella Koch-Ocker at Cornell University went back through years of data from Voyager 1's plasma wave system, looking carefully at the quiet periods between the solar shockwave events. And they found something extraordinary hiding in the background. A continuous, steady, extremely faint signal, a persistent hum, not a burst, not a flare, not a momentary spike, a constant narrow bandwidth emission that appears to be the sound of interstellar plasma itself, the charged gas that permeates the space between stars, vibrating gently and continuously all on its own. The research was published in May 2021 in the journal Nature Astronomy, and it was a landmark moment. Before this discovery, scientists could only measure the density of interstellar plasma when one of those solar shock waves came along and lit the plasma up like a camera flash illuminating a dark room. Those events only happened roughly once a year, so the map of what the interstellar medium actually looks like was patchy and incomplete. Now, with this continuous hum, Voyager 1 can measure the density of interstellar plasma in real time, constantly, regardless of what the sun is doing. As one scientist put it, Voyager is like a probe dropped into the ocean saying, "Here is the density I'm swimming through right now, and here it is now, and here it is now." For the first time, we have a continuous, real-time measurement of the interstellar medium, updating as the spacecraft drifts deeper and deeper into that unknown territory. In 2020, Voyager 1's magnetometer, which measures the strength and direction of magnetic fields, registered a sudden and significant jump. The magnetic field intensity around the spacecraft increased sharply and noticeably. At the same time, the plasma density readings also rose. Now, scientists had seen temporary jumps like this before. Occasional surges from the sun would compress the interstellar plasma, intensifying the fields briefly before things returned to baseline, like a wave washing over you and then receding. Scientists expected the same thing to happen with these 2020 readings. They waited for the readings to come back down. The elevated magnetic field and plasma density readings continued for month after month, well beyond anything that had been seen before. And leading scientists began to question whether the explanation was still a solar pressure wave at all. One of the most intriguing theories came from Dr. Adam Sabo, an astrophysicist at NASA's Goddard Space Flight Center and the principal investigator for Voyager 1's magnetometer. His idea is striking. He believes Voyager 1 may have entered a small cloud of ancient interstellar plasma, a dense pocket of ionized gas that was expelled long ago by another star or by a star-forming region somewhere in our galaxy, and that has been drifting through interstellar space ever since. These old plasma clouds can carry their own magnetic fields, the remnant signature of the stars or cosmic events that created them. And if Voyager 1 flew into one of these ancient clouds, it could explain why the elevated readings did not fade away the way solar-driven events normally do. The magnetic field embedded in such a cloud would simply be a physical property of the cloud itself, not a temporary ripple from the sun. If that is what Voyager 1 has found, it would be a remarkable discovery. We have never been able to directly sample one of these interstellar clouds before. We have observed them from a distance through astronomical instruments, but actually flying through one, measuring the plasma density and magnetic field properties from the inside, in real time, that would be completely new territory. A 2026 study published in the Astrophysical Journal, tracking Voyager 1's magnetometer data from the magnetic hump in 2020 all the way through mid-2025, found that the magnetic field has been showing persistent and complex behavior. From mid-2024 through early 2025, the field stabilized around 0.50 nanotesla before showing signs of decreasing again. Scientists say that as of mid-2025, Voyager 1 has not yet entered a pristine region of undisturbed interstellar space. It continues to move through a perturbed environment, still shaped by forces that are not fully understood. Think about what that means. We sent a spacecraft into interstellar space over a decade ago, expecting to find a quiet, predictable emptiness. And instead, we have found a place that hums with plasma, where ancient magnetic clouds drift through the void, where the boundary between our solar system and the rest of the galaxy is far more complex and dynamic than any of our models predicted. Voyager 1 is not just crossing empty space, it is crossing territory that has a history, that has structure, that is shaped by billions of years of stellar births and deaths and explosions and magnetic fields that have been traveling through the darkness for longer than Earth has existed. Now, there is another dimension to the Voyager 1 story that is impossible to separate from the scientific discoveries, and that is the story of the spacecraft itself. Because while it has been making these discoveries, it has also been fighting for its own survival in ways that have stretched the abilities of the NASA engineers who look after it to their absolute limits. In November 2023, Voyager 1 had a crisis. The spacecraft started sending back garbled, unreadable data. The transmission looked like the outputs of a system that had completely broken down. Mission control at NASA's Jet Propulsion Laboratory could not read it. They could not understand what the spacecraft was trying to say. And with a signal taking 23 hours to travel one way, every attempted diagnosis and repair was agonizingly slow. You send a command, you wait 23 hours for it to arrive, you wait another 23 hours for the response to come back. Nearly 2 full days pass for every single exchange. Imagine trying to fix your computer remotely when every mouse click takes 2 days to register. The team spent months working the problem. In April 2024, they made a breakthrough, and they figured out that the issue was with one of the spacecraft's flight data computers, A chip responsible for storing a portion of the onboard software had been corrupted. The solution they came up with was creative and extraordinary. They could not simply rewrite the software the normal way, because there was not enough memory in any single other location on the spacecraft to hold the full corrupted section. So they broke it up. They divided the affected code into pieces and stored each piece in a different section of Voyager's available memory. Then they updated all the other parts of the software to know where to look for each piece. It was like rewriting a book by scattering the chapters across different rooms and then drawing a new map to tell everyone where each chapter is hidden. The repair worked. By June 2024, Voyager 1 was back to returning normal science data from all 4 of its active science instruments. The relief and pride at JPL were palpable. A 47-year-old spacecraft, 15 billion miles away, had been brought back from the brink by engineers working through a 46-hour round-trip communication delay. But the engineers know the time is running out. The plutonium batteries have been losing power for decades. In February 2025, NASA made the difficult decision to shut down the Cosmic Ray Subsystem, a set of 3 telescopes that had played a crucial role in confirming when and where Voyager 1 first crossed the Heliopause back in 2012. Shutting it down was the only way to preserve enough power for the instruments that matter most right now. As of early 2025, 3 instruments remain active on Voyager 1, the magnetometer, which measures magnetic fields, the plasma wave subsystem, which detects those plasma waves and the interstellar hum, and the low-energy charged particle detector, which is scheduled to be switched off in 2026. After that, only 2 instruments will remain. Engineers believe that with careful power management, they may be able to keep at least 1 science instrument operating into the 2030s. That would give Voyager 1 more than 5 decades of scientific operation. But every year is uncertain. Every year requires new decisions about what to sacrifice to keep the most critical systems running. The spacecraft that was only supposed to last 5 years has now outlasted every expectation by an almost incomprehensible margin. And in that extended lifetime, it has gifted science with discoveries that nobody planned for and nobody could have predicted. Here's something I want you to sit with for a moment. Voyager 1 is carrying something on board beyond its scientific instruments. It carries a golden phonograph record, 12 inches across, gold-plated copper, protected by an aluminium cover. On that record is a message from humanity, assembled in 1977 by a committee chaired by the astronomer Carl Sagan. It contains sounds from Earth, waves, wind, thunder, birds, whales, a baby crying, the music of different cultures from around the world, greetings in 55 different languages. It contains scientific information about where Earth is and what life on it looks like. It was put on board just in case Voyager 1 was ever found by someone, or something, that was not human. It is the most ambitious message in a bottle ever thrown into the widest ocean imaginable. That record is out there right now, 15 billion miles from home, hurtling through interstellar space at 38,000 miles per hour, passing through an ancient plasma cloud, listening to the hum of the stars, measuring magnetic fields that have existed since before our solar system formed. And it is still talking to us. Still sending its whisper of a signal, 23 watts of radio power, the same wattage as a dim light bulb across 15 billion miles of space, back to the dish antennas of NASA's Deep Space Network on Earth. The fact that we can still hear it is astonishing. The fact that what it is telling us is still scientifically groundbreaking nearly half a century after launch is something beyond astonishing. It is one of the greatest achievements in the history of human civilization. What does all of this mean for the future? The data that Voyager 1 is sending back right now is being used to design and plan the next generation of deep space missions. Future interstellar probes, concepts that scientists and engineers are already sketching out, will be built with the knowledge that the interstellar medium is not empty and predictable, but complex and structured. They will know to look for ancient plasma clouds. They will know that the hum of interstellar gas is there to be measured. They will know that the boundary between our solar system and the rest of the galaxy is not a clean line, but a messy, turbulent, magnetically charged zone that extends far further than our original models predicted. None of that knowledge would exist without Voyager 1. And in the meantime, the spacecraft itself is still out there, still pushing into the unknown, still crossing distances that have never been crossed by anything human-made. By November 2026, it will be one full light day from Earth. 1 day's travel for light from our planet to that spacecraft, a distance that puts it genuinely in the deep wilderness of interstellar space, far beyond any meaningful connection to the world that built it. And yet it will still be listening to the space around it, still measuring, still reporting back. Sometime in the 2030s, the last instrument will go silent. The batteries will finally be too depleted to power anything. The signal will stop, and Voyager 1 will continue on in silence, an artifact of human curiosity drifting through the galaxy forever. Astronomers have calculated that in approximately 40,000 years, Voyager 1 will make its closest approach to a nearby star called Gliese 445, passing within about 1.6 light years of it. Whether anything will ever find it is a question that belongs to a timescale so vast that human imagination struggles to contain it. But for now, it is alive. For now, it is talking. For now, it is discovering things in a place that no probe has ever been, giving us our only real glimpse into the true nature of the space between the stars. A 48-year-old spacecraft, running on the power of a nightlight, floating through ancient cosmic clouds, listening to the hum of the galaxy, and still sending that signal home. There is something profoundly beautiful about that, and profoundly human. We built something, sent it out into the dark, and it just kept going. Further than anyone thought it would, longer than anyone thought it could, and from the edge of everything we have ever known, it is still telling us what it finds. That is Voyager 1. That is what it discovered. And what it means is this. The universe is stranger, richer, more complex, and more magnificent than we knew. And we know it because we had the audacity to throw a gold record and a few instruments into the dark and see what came back. For most of human history, the space between the stars was considered to be essentially nothing. A void. An emptiness so complete that nothing meaningful could happen in it. Stars were the objects of interest. Planets were the objects of interest. But the space in between was just background, just the nothing that separated the somethings. And then Voyager 1 went there, and everything changed. The interstellar medium is not nothing. It is a thin but real substance filled with atoms, ions, magnetic fields, cosmic rays, and plasma waves. It has structure. It has turbulence. It has regions of different density, ancient pockets of gas expelled from stars that exploded millions or billions of years ago, drifting slowly through the galaxy in ways that we are only just beginning to map. When Voyager 1 detected that persistent plasma hum, it was revealing that even in the near vacuum between the stars, there are processes happening continuously. The interstellar medium is alive with activity, just activity on scales and at intensities that are nearly impossible to detect without being right there in the middle of it. Think about what that means for every star in our galaxy. Every star, including our sun, sits in a bubble carved out by its own stellar wind. And every bubble is surrounded by this active, structured, magnetically complex interstellar medium. The way that medium behaves around a star affects how that star's protective bubble is shaped. It affects the cosmic ray environment inside the bubble. And cosmic rays, high-energy particles streaming in from the galaxy, can affect everything from the evolution of planetary atmospheres to the chemistry that makes life possible. By understanding the interstellar medium, we are understanding the environment that shaped every planetary system in our galaxy, including our own. The ancient plasma cloud that Voyager 1 may have entered, if Dr. Sabo's theory is correct, is a piece of cosmic history. It could be the ejected material from a star that died in a supernova explosion millions of years ago. That explosion sent matter and energy blasting outward at incredible speeds, and some of that material, compressed and magnetized, may still be drifting through our galaxy in clouds and filaments and pockets of ancient plasma. Voyager 1 may be sampling material that was once inside another star, material that predates our solar system, material that carries the imprint of stellar processes and energies that happened long before Earth existed, and yet whose remnants are still out there, still moving, still shaping the structure of the space our solar system is flying through. There's also the matter of what these discoveries mean for the future of human space exploration. We are still a civilization that has never sent a human being beyond the moon. We are still a civilization whose robotic probes, the fastest things we have ever launched, take decades or centuries to reach even the nearest stars. The nearest star system to our own, Alpha Centauri, is about 4.2 light years away. At the speed Voyager 1 is traveling, it would take roughly 75,000 years to reach it. That gap between where we are and where we want to go is humbling, but it is also motivating. Scientists and engineers around the world are working on ideas for faster interstellar probes, concepts that use laser propulsion, solar sails, nuclear pulse drives. None of these technologies exist yet at the scale needed for an interstellar mission, but they are being seriously studied and planned. And every one of those future missions will be designed with the knowledge that Voyager 1 has given us. The interstellar medium is not empty. It is structured. It hums. It has clouds. It has magnetic fields. Any future probe will need to be designed to measure and survive in that environment. And thanks to Voyager 1, we now know what that environment actually looks like from the inside. There's one more thing that I think deserves to be said, and it is something that the engineers and scientists who work on the Voyager mission think about deeply. Voyager 1 was not supposed to still exist. It was not supposed to still be working. It was designed for a 5-year mission. The fact that it is still alive 48 years later, still making new discoveries, is not just a testament to 1970s engineering. It is a testament to the decades of dedicated work by the people at NASA and JPL who have kept it going. Engineers who have had to diagnose problems on a spacecraft 15 billion miles away, using computers that they can barely communicate with. People who grew up hearing about Voyager 1 as children and then devoted their careers to keeping it alive. People who will live to see it go silent and will feel that silence is something personal. When that last signal finally comes, when Voyager 1's batteries fail and the faint whisper of data finally stops, it will be a moment of both ending and permanence, because the spacecraft itself will not stop. It will keep flying through the interstellar cloud, past the anomalies in the magnetic field, out into whatever lies beyond that forever. It will drift through the galaxy long after us.